Alright, hi everyone, welcome back to the channel. So today I'm going to be participating in Codeforces round 891. This is a division 3 round. It's going to be 2 hours 15 minutes long, and the target is going to be to at least try and solve all the problems. Okay, cool. So yeah, also I have kind of a special announcement for you guys towards the end of the video. So yeah, I'm looking forward to that, and stick with me till the end. Okay, cool. So yeah, also I am pretty tired today because I have just come back 5 minutes ago from office, so I am kind of tired, but I think it's still worth it to participate. So yeah, let's start. Oops, looks like Codeforces is doing something funny here. Alright, so here we go. 7 problems, and it's time to start with the first problem. Okay, what just happened? Something weird is going on. Anyways, okay, so you are given an array consisting of n integers. Just your task is to determine whether it is possible to color all its elements in 2 colors in such a way that the sum of the elements in both the colors have the same parity, and each color has at least one element colored. What does that even mean? Okay, alright, so we need to divide it in 2 sets such that the sum has the same parity, right? So all that we're trying to do here is obviously the sum of all the elements in the array should be even, because both of them have the same parity, so their sum would become even. So that's fine. And if there is more than one element and the sum is even, then we can pretty much always do that, right? Yeah, so if the sum is even, then we can just keep one element and all the other elements. We can just color the first element with one color and all the other elements with another color, and the parity is going to be the same. Okay, cool. So yeah, let's just create a variable sum equal to 0. So read the input sum plus equals to x. So if sum is even and n is greater than 1, then our answer is going to be yes. Okay, should work. Alright, let's quickly submit this, move on to the second problem, if Codeforces allows me to. Right. Cool. So given a natural number x, you can perform the following operation. Choose a positive integer k and round x to the kth digit. Note that the positions are numbered from right to left starting with 0. If the number has k digits, consider that the digit at the k plus 1th position is equal to 0. Rounding is done as follows. If the digit at the k minus 1th position is greater than or equal to 5, then the digit at the kth position is increased by 1, otherwise the digit at the kth position remains unchanged. If before the operations the digit at the kth position was 9 and it should be increased by 1, then we search for the least position k prime. Okay, let's just look at the examples. We choose the first operation. Round x to the kth digit equals to 2, then 3500. Okay, k is equals to 3, then what do we get? K is equals to 4, then we get 0. To maximize the answer, you need to choose k equals to 2 first, then k equals to 3, then the number will become 4000. Maximize x as large as possible. Okay, I see. Okay, so we are starting from 0. That makes sense. And the digit at the kth position was 9 and should be increased around. Then we search for the least position k prime where the digit at the given position is less than 9 and 1 to that position. Then okay, that makes sense. Alright. So do we need to make only one operation? Okay, so we need to make only one operation. That's fine. So basically what we are trying to do here is to maximize the number. So obviously what we need here is that the number which is being increased should be as left as possible, okay, if at all we are increasing any number. And if any number is not getting increased, then we are basically just decreasing the number. So then we don't really need to perform any operations, okay. So essentially we just need to search for a digit which is greater than or equal to 5. Yeah, so we need to search for the rightmost digit which is greater than or equal to 5, okay, and then towards its left we need to find the first digit which is not a 9. We need to increment that by 1 and then we need to append all the other elements as zeros, okay. Right, that makes sense. Cool, so let's just implement that. So we'll get a number x, so let's just say that it is n and it's a string. So we have this number, okay. So what we'll do is we'll find the first position where we have a digit which is greater than or equals to 5, okay. So digit would be n of I minus 0, okay. We'll say position is -1 and if this digit is greater than or equal to 5, we'll say pos equal to I and then we'll break out, okay. Now if this pos is equal to -1, that means all the digits are smaller than 5, then no matter what operation we do, we always end up decreasing our number, right? So then we'll just output n and we'll continue. Else what we need to do is, so we'll go from right to left starting from pos, okay. So for I is equals to pos -1 and I is greater than or equals to 0, I minus minus, and then let's just define another variable, final pos, and let's say that it is -1, okay. So in that case we'll just check if we found a number which is not equal to 9. So if s of I minus 0 is not equal to 9, then we'll say final pos is equals to I and we'll break out. So now if final pos is equal to -1, then that means that all the numbers before us were 9s, okay. So then we'll just say that answer is equal to 1 and for the entire size of the string we'll just append zeros. So answer plus equal to 0. Yeah, that makes sense. Otherwise, we'll say that answer is equal to n and answer of final pos plus plus and all the other elements to the right of it would become 0. Okay. Let's quickly debug this one. Might have some errors. 1, 10, 100, 1000, 2000, 2444, 21,000. That's wrong. 7th test case. Let's see. Oh, we can perform this operation as many times as we want. Okay, cool. So that is something that I have missed. Okay. So how can we make this 2100? So in the first step we'll make it 20450. Okay, and then we'll make it 20500, and then we'll make it 21000. Okay, yeah, that makes sense. Okay. Anyways, we are still getting some wrong results here. What is final pause? Final pause is 3, that's correct. Okay, so if final pause is not equal to -1, that should be there. Equal to -1. So now we are getting 20450, but that's not what we want. So when we encounter a number greater than or equal to 5, we will increase the digit which is to the left of it, okay, which in turn again becomes 5, so then we can again make it 0, right? So I think the only corner case here is when we get a string of 4s, so we can make all of those 4s also equal to 0, right? Right. So what we can do here is we can say that final pos minus minus, or maybe while final pos -1 is greater than equal to 0 and n of final pos -1 equals to 4. Okay, we'll say final pos minus minus. That sounds better. So if while final pos is greater than equals to 0 and n of final pos minus 1, n of final pos equals to 4, right? Yeah, so we can do final pos minus minus. So we can do this here itself. Wait, what am I even doing here? So why is this check even required? Yeah. Yeah, this should work fine, hopefully. Cool. So this was a pretty damn irritating problem, I would say. So let's move to problem C now. Hopefully that would be better. Anyways, so Sasha has an array of n integers. He got bored, and for all ij, he wrote down the minimum value of ai and aj. He obtained a new array b of size nc2. Okay. Then he randomly shuffled all the elements of the array B. Unfortunately, he forgot the array A, and your task is to restore a possible array A for which the array B could have been obtained. Makes sense. The elements of the array should be in the range minus 1e9 to 1e9. This sounds interesting. This is probably a better problem than problem B, I would say. Okay, so let's think about this one. So we have an array and we took the minimum of all the pairs, right? So let's say that the array was sorted originally, because without loss of generality we can always assume that. So if we look at the minimum element should occur exactly n minus 1 times, okay? And the second minimum element should occur exactly n minus 2 times. So that way we can do stuff, right? But then there is also that added possibility that the elements are equal, in which case we'll have to change some things. So basically we can maintain a count of counts, okay? So how yeah, that sounds like a good idea. Yeah, so basically that's what we can do. Yeah, so let's just simulate the process. We already know what are the counts and what should be the required counts, so let's just do that. Okay, so the number would be n into n minus 1 upon 2, and let's maintain what, a map or something. Yeah, right. So the distinct number of distinct elements in the map would not exceed 10 to the power 3, so that should be good. Yeah, let's just maintain a map count. Okay, so let's try and build the answer in the sorted form. We can output any order, right? Output any possible array, right? So the ith element should have a count exactly equal to n minus I, right? It's minimum, right? Yeah. So we need to look for the smallest element which has a count greater than or equal to n minus I, and that should do our job. Okay, so yeah, so ll cur equal to -1, then we'll just iterate over our map count, and we'll say, okay, we have to iterate by reference. Maybe not. Yeah, so if x dot second is greater than or equals to n minus I, then we'll say cur is equals to x dot first, and we'll break out. We can assert that cur is not equal to -1. We can say that a of I is equal to cur, and then we can say that count of cur minus equals to n minus I. Okay, yeah, that sounds like a good enough solution. Okay, that shouldn't happen. Okay, so -1 could be present, but I don't think that's an issue here. Oh, so we need to take input till here. That's the problem, I think. Yeah, we're getting results, but the results should be sorted. Oh, okay. So if count of cur is equal to 0, we'll say count dot erase cur. And I is not equal to n minus 1. So there is also this one case where count is becoming equal to 0. We need to somehow handle that. So what we'll do is, if I is not equal to n minus 1, then we'll break, but if I is equal to n minus 1, then we'll not break. Why is that happening now? we're only getting a 1 here. That doesn't sound right. Why is that happening now? I'm just doing something wrong, and okay, so it should be I is equal to n 133 10 10 3577. Yeah, that sounds about right. Oh, maybe it doesn't even matter because the last element can be literally anything. But yeah, let's submit this. Should work. Alright, I'll be back in a moment. So now let's try problem D. Looks like some sort of a geometry problem. So given two arrays A and B, both of length n, elements of both arrays are indexed from 1 to n. You are constructing a directed graph where the edge from U to V exists if AU minus AV is greater than or equal to BU minus BV. Okay, a vertex V is called strong if there exists a path from V to all other vertices. Make sense? A path, I know what a path is. Your task is to find all the strong vertices. Number of strong vertices, all the strong vertices in ascending order. Yeah, that makes sense. Now how do we do that? So the first thought that I'm having is, if there is an edge from, let's say, I to J and then from J to K, what does that mean? So the basic condition is that AI minus AJ should be greater than or equals to BI minus BJ, right? Yeah. Oh. So this sounds pretty straightforward to me because like if there is an edge from I to J and there is also an edge from I to K, then there is bound to be an edge from I to K as well, because let's say AI minus AJ is some value, then AJ minus AK is definitely smaller than that. Okay, so this sounds like a good observation. Oh, okay. So this value is denoted by AI minus AJ. AI minus AJ is what? It's greater than or equal to BI minus BJ, and AJ minus AK is greater than or equal to BJ minus BK. Well, essentially we can just swap places here, I think. So we can swap BI and AJ here, and this inequality transforms to AI minus BI is greater than AJ minus BJ. So now the observation that I made initially is true, and if there is an edge from I to J, then that means AI minus BI is greater than AJ minus BJ, and in turn that means that AJ minus BJ is greater than or equals to AK minus BK. So there is also an edge from I to K. Okay, cool. So What I mean by that is basically we can sort all of them by their values of ai minus bi, and the element which has the greatest value will have an edge to all the other elements. Okay, and it will be kind of like a directed acyclic graph where edges will be only directed from left to right, from elements which have a greater value of ai minus bi to those which have a smaller value. Okay, and I think we only need to output the count of the maximum element in ai minus bi. Okay, so let's see how they have done it. There's just one element 4, that's right. And there are two elements 3 and 5. So for 3 this value is 1, for 5 this value is 1. I think that's it. So let's just quickly code it up. So we'll create another array. Okay, vector of pairs c. Okay, now ci is going to be ai minus bi comma I. Okay, now we'll just find out the maximum element here. Maximum is the maximum value of ci dot first. Okay, now we'll create an answer vector and we'll just say if ci dot first is equal to maximum, then answer vec dot pushback ci dot second sort all answer vec. Alright, so let's test it out. Whoops, what happened there? That shouldn't happen. Oops, looks like I've taken input in the wrong format. Yeah. ci is equals to ai minus bi comma I. Should be good now. 1 2 1 2 3 2 2 3. Yeah, looks fine. Let's quickly submit this, move on to the next problem. This should pass. Alright, problem E. So you are given n positive integer coordinates x1 to xn which lie on a number line. For some integer s, we construct segments from s to x1, s to x2, s to xn, so on and so forth. Okay. Note that if xi is less than s, then the segment will look like xi to s. Okay. Alright, so we define the power of a point P as the number of segments that intersect the point P, that intersect the point with coordinate P, denoted as FP. Okay. So basically the number of segments in which the point P lies, right? They could have written it in a much better way. So your task is to compute FP for all the numbers from 1 to 10 raised to the power 9. Okay, that makes sense. Okay. There is a sum of FP over all points from 1 to 10 to the power 9. Okay, so again this doesn't sound that hard to me. Okay, why are we outputting 3 values? N integers equals sum of the power of all points for s equals to xi. Oh, okay. Okay, for each s belongs to x1 to xn. Okay, now this problem is much more challenging. All right, so let's see how we can do that. So we have these n points. Okay, let's say we have them in the sorted order. Okay, points can be from 1 to 10 to the power 9. That's good. So let's say that we have s is equals to this third point. Okay, so what will be the value of f of this third point? Well, it's just going to be, well, let's say we are considering this particular segment. So this particular segment, let's say this point is x and this point is y, then it will be simply adding y minus x to our answer, right? So essentially I think all we are trying to find here is the sum of the absolute differences of all the elements, in which the first element is x and the second element can be anything. Okay, so that we need to find for all the other elements. So let me just verify if that's correct. So for 1 the answer should be, okay, so it doesn't seem to be correct. Oh, okay, yeah, so it's not that, it's like the difference plus 1. Okay, so for 1 we'll add 1, and here we'll add 4, and here we'll add 3. Okay, that makes sense. Yeah, so we can simply add n to our answer for every element. That's fine. So for 4 we should get 3 plus 1 plus 4, right? 3 plus 1 plus 3, yeah, 7. Yeah, that's correct. Cool, so I think that's what we are interested in. Let's just quickly code that up. That's pretty easy to do. So once we have this sorted, all we need is to build the prefix sums. Okay, so prefix sums of I is equals to prefix sums of I minus 1 plus ai dot first. Okay, cool. So we have an answer. Okay, fine. Let's just initialize this with the value n. Now all the elements which are to the right of me, for all the elements which are to the right of me, I will add aj minus ai. So essentially I will need the sum of all the elements to the right of me, and then I will just subtract n minus I times ai. Okay, so I'll say answec of I plus equal to, that would be what, p sum of n minus p sum of I minus p sum of I. Okay, from this I will subtract n minus I times ai dot first. Okay, this should be ai dot second. Okay, and for all the elements which are to the left of me, I'll add ai minus aj. Okay, so then I'll do answec of ai dot second plus equals to p sum of I minus 1 minus I minus 1, sorry, this should be I minus 1 times ai dot first. Okay, minus this sum of all the elements from 1 to I minus 1, so that would be simply p sum of I minus 1. Okay, alright, so let's just test this out. 8, 7, 6, 16, 15, 18, 24, 16 sounds right. Alright, so looks correct. Let's submit this. Problem E I think was relatively an easier problem, if at all we get it accepted. Cool, so we're done with 5 problems. Let's move to problem F now. You have an array A of length n. Your task is to answer Q queries. Given xy, find the number of pairs I and j such that I is less than j, that both ai plus aj equals to x and ai times aj equals to y. Wow, that's nice. Sounds like an interesting problem. So I should be strictly less than j. Okay, so we need the number of pairs, number of ordered pairs, unordered pairs, such that their sum is equal to x and the product is equal to y. Both x and y are pretty big, so that would definitely pose some problems for us. But wait a minute. If we know both the sum and the product, we have two numbers, we have two equations and two variables essentially. So that should make our lives much easier. Okay, we can essentially solve it, right? Yeah. So what they're trying to say here is ai plus aj is equal to x and ai times aj is equal to y. Okay, so what we can do here is we can write aj as y upon ai and get something like this. Okay, so then we'll get a quadratic equation. So that would look something like ai square minus x times ai plus y is equal to 0. Okay, right, now what? Now we need to solve this equation. We can easily find the value of ai and consequently we can find the value of aj. Okay, and then when we can just multiply their counts and that would give us the answer. Okay. Now the only question is, how would I solve this quadratic equation? So there are a few ways I can do this. So one of the ways is by using ternary search. Okay, so we can use ternary search to solve quadratic equations, and the other way is to just simply apply the quadratic formula. Okay, both of these ways should work in this problem. Okay, let me think which way should be better. I think we should just go with the quadratic formula thing. Yeah, I think that would be much easier. So let's do that. So we have all the numbers. Taken both x and y. Okay, so now we are looking for the value of ai and we know the quadratic formula. Okay, so first of all, the discriminant should be a perfect square. Okay, since we are dealing with integers, so the discriminant should be a perfect square. So discriminant is called b square minus 4ac, which in turn here is x square minus 4y. So that should be greater than or equal to 0, and that should also be a perfect square. Okay, let's just write a function find square root or my square root. Answer is square root of n. I is equals to max of 0 ll answer minus 5. I is less than equals to answer plus 5 I plus plus. So if I into I is equal to n, then we'll just return I. Okay, that sounds about right. Cool. So then what we'll do is discriminant is equal to x square minus 4 into y. Okay, so if discriminant is equal to 0, if discriminant is less than 0, so if this discriminant is less than or equal to 0, we'll just output 0 and we'll continue. Okay, cool. Now we need to check whether the discriminant is a perfect square or not. So let this value sq be the square root of discriminant. Okay, so if this sq into sq is not equal to discriminant, then again we'll output 0. Also, the parity of x and sq should be same. So if x plus sq plus 2e9 modulo 2 is not equal to 0, then we'll see out 0. Okay, this 2e9 is here only because this value x plus sq can also be negative. Okay, that's the only reason. Can it? Yeah, it can. Right, then the value of ai would be, so ai is going to be what? X plus sq divided by 2. Right, so aj is going to be what? Y divided by ai. Okay, so or x minus ai. Okay, so we can simply output count of ai multiplied by count of aj. Okay, so I'm getting a wrong answer for the second test case. Let's see, why is that? Okay, that sounds weird. Oops, this should be here. Oh, so if AI is equal to AJ, it's a corner case. Count of AI into count of AI minus 1 upon 2. Six, yeah. That sounds right. Let's just cross check if we haven't missed anything out. So we are finding the square roots correctly. I into I less than equal to n, I plus 1 greater than n. Okay, so discriminant is negative, then we continue. Square root should discriminant should be a perfect square. The parity of x and the square root should be the same, so their sum should be even. Cool, so x plus square root by 2 and x minus AI. Yeah, this sounds about right. Let's just submit this. Looks like this is working. We have problem G opened. And it seems that problem G is a counting problem, but the good thing is that we have a lot of time at hand to solve problem G. So just give me a moment, I'll be back. Alright, so looks like we have passed problem F. I don't know why they put such a generous time limit here. It's just weird. Okay, so moving on to the final problem. Seems like it again is not extremely hard, but let's see. So given a tree consisting of n vertices, a tree is, I know what a tree is. Each edge has a weight wi. Your task is to count the number of different graphs that satisfy all the 4 conditions. The graph does not have self loops and multiple edges. The weights on the edges of the graph are integers and do not exceed the number s. Okay. The graph has exactly one minimum spanning tree. The minimum spanning tree of the graph is the given tree. Okay. Makes sense. Two graphs are considered different if their sets of edges are different, taking into account the weights. Okay. Let's change the modulo first of all, because I really don't want to get a wrong answer because of wrong modulo. Okay, now let's see what we can do here. S is up to 10 to the 9, n is up to 2 into 10 to the power 5. Wi's are less than or equal to s. The weights of the edges on the graph Okay, what is the sense of these weights? What happens if we just forget about the weights? When does the graph have exactly one minimum spanning tree? Either the graph is equal to the tree, okay, or the graph is not equal to the tree. In that case, we will have at least one cycle, okay. And what if we have more than one cycles? So if we have more than one cycles in the graph, so if we have more than one cycle, we have the liberty to remove two edges, okay. And if we have the liberty to remove two edges, then that means that the number of MSTs is also 2, right? Okay. Number of different rows. So if all edge weights in a connected graph G are distinct, then G has a unique period. That is something that I know. So this is a possible graph and it has two cycles. That's interesting. It's really interesting. Okay. Number of graphs which has this tree as the minimum spanning tree. If we are adding any edge in this tree, then it will be forming a cycle, okay. But we need to make sure that all the elements which or all the edge weights which appear in this cycle should satisfy some properties, okay. Now what are these properties? So here's the thing. So let's say we have some elements and we try to add an edge between these two elements. Okay, now there are some edge weights here. Okay, now if we find any edge weight, let's say y and x, if we say that the weight of the edge here is x, and if the value of x is smaller than or equal to y, then we can just remove y from the MST and add x to it. Okay, and we can leave the rest of the graph the same. Okay. And everything will still be connected. Yeah. I think this is the only property that any edge that we are adding should satisfy, according to me. So if we are adding an edge between 2 and 4, what is the value of s here? S is 5. Okay, so s should be greater than 4, right? Again, can only add 5. Yeah. I think this is the only property that the graph needs to satisfy. So if the value of n was smaller, we could have simply looped around all the pairs and then just found out the minimum value of the edge between them, and we could have added any value of edge between those two nodes such that the value of that edge is greater than the maximum in the path. Okay, all right. So what we can do then is, I think we can apply DSU in this graph. So basically we can sort all the edges by their weights. Okay, we can just keep adding these edges one by one. Okay, and yeah, I think that's the solution. We can just keep adding these edges one by one, and we can find out the contribution of every number. Okay, so basically we'll just try to find how many edges can we add in this tree such that the value of that edge is equal to x, and to do that we look at the state of this tree when we have only processed the edges whose values is strictly smaller than x. Okay, and then all we need is the number of nodes which are reachable from each other. Okay, so we somehow need to manage the number, we somehow need to maintain the number of pairs which are reachable from each other. Okay. So that can be done very easily with DSU, I think. Yeah, so we just need to manage the number of pairs which are reachable from each other, because we can then add an edge there. Yeah, I think that's it. So let's try and implement this. So let's first modify this DSU function. So we need another variable num reachable. Okay, which we'll initialize to 0. And we'll also need the sizes. So let's just do union by, or let's just maintain this value sys. Okay, sys of I is equal to 1. Okay, so sys of u plus equal to sys of v. This way we are maintaining the sizes. Cool. So now we also need num reachable. So if u is equal to v, then I don't think we need to make any changes because all of those nodes were already reachable, right? Otherwise, what we can do is we can say that num reachable minus equal to sys of u into sys of u minus 1 upon 2, num reachable minus equal to, so replace u by v here, sys of v minus 1 upon 2. Okay, but now all the nodes in this component are reachable from each other, so we'll say num reachable plus equal to sys of v into sys of v minus 1 upon 2. Okay, sorry, this should be u. Right, I think that's it. So we're done with the DSU. So let's see, we have N and S. Okay, cool. So let's take in all the edges. Pair of nodes will have Vertices, right? We just need the number of pairs of nodes which have, let's say, 5 choices, and then the number of pairs which have 6 choices, and then we'll add 5 to the power that number. We'll multiply 5 to the power that number to our answer. Okay, so yeah, that sounds about right. So let's say we are looking at an edge weight w and we have processed the tree with all the edges less than w. Okay, and then we are trying to find out the number of pairs which will have s minus w choices. Okay, and the number of such pairs would be simply the size of the component of u multiplied by the size of the component of v, right? Yeah. and we are looking at a tree, so it will never happen that both of them are already in the same component. Okay, yeah. Right, so let's process these edges. J is equals to I, so Ij is Ij is less than n minus 1, and edges of j weight is equal to edges of I weight. We'll do j plus plus, and we'll do union set of edges j0, edges j1, I is equal to j minus 1. Okay, now what we have is before processing all this, we have the contribution of what? So I don't think it's that simple, since these edges can have duplicates as well. So how to handle that? I think we can just process them together. Yeah. Instead of doing union set, we can say country is equal to 0, and country plus is equal to sis of edges is 0 multiplied by sis of edges j1. Okay, and now we'll do the union, and we'll say answer is equal to 1. So what can we do here? So between each edge, between each pair, we can add an edge, and say the maximum element is 5, so we can either choose not to add an edge, so we have one pair which already has this edge. We can't have multiple edges, obviously. Oh, right. We'll also need to. Okay, so that makes it much more complicated. Right. What will be this contribution? If let's say the maximum element between two nodes is 4 and the value of s is 5, then we can either decide to, so we can add an edge of, basically we have like one choice, right? Yeah, we have one choice, we can add an edge 5. What if I decide to not add an edge? Yeah, that's also a choice, right? So I have s minus edges I2 plus 1 choices, right? Yeah. But some of them may already have edges. Now how to deal with that? Oh, that won't happen. Obviously that won't happen. We are dealing with a tree. Yeah, so that wouldn't happen, obviously. Okay, so let's see if this is working. Yeah, what's the problem here? We don't, yeah, so we're getting wrong answers. That shouldn't happen. Second test case we are getting 1. Okay, that's weird. We have 2, 3 and 4. Four zero, 2 0 and 3 0. Okay. Okay, so this should be fine set, I think. We're getting wrong answers. 18. That's weird. Alright, I'll be back in a moment. So the problem here is that I'm not sorting by weights first of all, so that's another problem. So we need to replace this 2 by 0 by 1 and by 2. This should be 0, this should be 1, this should be 2, and this should be 0. Let's write it down. So this graph essentially between 1 and 2 we have no options. Between 1 and 3 what do we have? So between 1 and 3 we can either add an edge of length 5 or we can add no edge. Okay. Between 1 and 4 we can either add an edge of length 5 or we can add no edge, right? Okay. Between 2 and 3 we have no choice. Between 2 and 4 we can either add an edge of length 5 or leave it as it is. So that's why we have 2 raised to the power 3. Okay. So instead of 3 we should have 2. Okay, so this should be 0. Yeah. Okay, so it's passing the samples. Let's just submit this, and I think this should work. I mean, I don't think I have left anything out here. Oops, we're getting a wrong answer. That doesn't sound right at all. Why is that happening? Wait, how can we even get a 0 here? Wait, what? Okay, so we are getting a 6. 6 is not possible, so let's say 10. 5 is correct because we can either leave this edge from 1 to 3 empty, or we can add anything from 7 to 10. That's correct. So we add another edge, 3 to 4, call it 7. And then what are we getting? 1 to 3 we have 5 choices. Between 1 to 4 we have 4 choices. Between 2 to 4 we again have 4 choices, right? We're getting 5 here. Between 1 and 3 we have 5 choices, and between 1 and 4 we also have 5 choices, right? This is clearly wrong. Okay, yeah, that makes sense. I think we don't really have to process all of them together. Yeah. Okay. Between 1 3, between 1 4, and between 2 and 4 we again have 5 choices, right? So we don't have to process everything together, and the reason for that is pretty clear. Yeah, I think this should work. let's try and submit it. Just pass the first 9 tests. So that was pretty stupid of me to process everything with the same value together, because that would just block some of the pairs, right? That would not count some of the pairs. So this should work. I mean, we've reached till the 34th test case, so I mean, I would be very disappointed if I failed now. Yeah, so we've passed it. Cool. I don't think a lot of strong people have given this contest, and that is why we are seeing such low amount of solves in problem G, because it is definitely not that hard. Okay, it is definitely not that hard. Cool, so I think we are done with this contest, and probably pretty much done with the screencast. I just have to make the surprise announcement that I had to make. So basically, the announcement is that I am bringing out a video for you guys in which I'm going to be sharing something which is pretty close to my heart, and a topic which is quite sensitive for me. Okay, I have talked about it quite a few times on my channel as well, but I'll be sharing an in-depth video about that. So yeah, you guys should be pretty excited about it. It will be out in around 2 to 3 days. Okay, so I'll make sure that I upload it at least in this week. Okay, so yeah, that's the announcement that I had to make, and I think we've come to an end of this video. So thank you so much for watching till the end if you did, and I'll see you in the next one.